Okay, get this. There's a fundamental rule of math you use literally every single day, probably without even realizing it. So today, we're going to break it down. We're talking about the commutative property, and we're going to do it by looking at it through, believe it or not, a 6th grade lesson plan. It makes it super clear. Let's dive in.
So let's just start with a basic question. I want you to think about your daily routine. When does the order you do things in completely change how everything turns out? I mean, think about it. You put on your socks first and then your shoes, right? Try doing that the other way around. Yeah, it's not going to work. But what if you're just adding a couple of numbers? Does the order really matter then? That simple little question, that's the key to unlocking a really powerful rule in math. Now, our source material uses this fantastic story to help us explore the idea. We're going to follow the story of Joseph, who's managing grain stores way back in ancient Egypt, to see how this whole concept plays out in a really physical, tangible way.
And this right here is the big idea from our source. This one sentence is the core principle we are unpacking. It sounds so simple, right? But trust me, it's the foundation for so much in mathematics. Let's see how it works.
All right, so how does this idea actually work in practice? Let's take that core principle and just apply it to some real numbers, and we'll start with addition.
Officially, this is what it's called, the commutative property of addition. I know, it's a fancy name, but it's for a super simple truth. When you're adding stuff up, you can swap the numbers around any way you want, and you'll always get the same answer, the same sum.
All right, let's get back to Joseph and his grain sacks. So picture this. He finds 5 sacks in one spot and then 3 in another. Okay, 5 plus 3, that's 8 sacks total. Easy enough. But wait a second, what if he went to the other storehouse first? Then he'd have 3 sacks plus 5 sacks, which, yep, is still 8. The order he visited them in made 0 difference to his final count.
So there we have it. For addition, it is confirmed order just doesn't matter. But does the same rule hold true when we start multiplying things?
You guessed it. Just like with addition, there is a commutative property of multiplication, and it states the exact same thing. You can change the order of the numbers you're multiplying, and it won't change the final product one bit.
Let's see this one in action. Joseph could decide to make 4 bundles with 3 sacks in each one. That's 4 times 3, which gives him 12 sacks. Or he could switch it up and make 3 bundles with 4 sacks in each. Well, that's 3 times 4, which is also 12. 2 totally different ways of organizing, but the total number of sacks is exactly the same.
Okay, so far we've been using specific numbers, right? 5s and 3s, 4s and 3s. But the real power of this idea, where it gets really cool, is when we take it from being specific and make it abstract, make it universal.
And this leads us to the most important question of all. Is this whole thing just a neat trick that happens to work with the numbers we've picked so far? Or is it a fundamental law of mathematics that is always true? How could we even prove that?
Well, this is where we make the leap from basic arithmetic to algebra. We take our concrete examples, Joseph's sacks, and we make them universal. We just replace the numbers with letters, with variables. So 5 plus 3 becomes x plus y, and 4 times 3 becomes a times b.
So is this a universal law? Yes, absolutely. When we say x plus y is the same as y plus x, we're not just talking about grain sacks anymore. We're making a huge statement. This is a rule that works for any 2 numbers you can possibly imagine, from the number 2 all the way up to 2 trillion and beyond. And that's how a simple little observation transforms into a powerful law of mathematics.
So what's the big deal? Why does this even matter? Okay, we've proven a simple rule, but the real question is, what's the bigger picture here? This isn't just a math trick, it's a fundamental truth about structure and reliability.
Now here's where it gets really interesting. The lesson plan we've been using as our guide takes this idea, this reliable, unchanging outcome, and it draws a pretty surprising parallel. It connects the certainty of this math rule to a much broader idea about how we can approach our work and our goals in life.
So the source material wraps up with this quote from Proverbs. Now the parallel it's drawing here is metaphorical, right? Just like the order of the numbers in addition doesn't mess with the final reliable answer, the lesson is kind of suggesting that if you commit to your work, you're building a solid foundation, a foundation that helps your plans come together, no matter which step you start with.
So let's do a quick recap of this whole journey. We saw that for adding and for multiplying, the order doesn't change a thing about the final result. We learned that this cool rule has a name, the commutative property. And maybe most importantly, we were reminded that sometimes the simplest rules are actually the most powerful, big ideas out there.
And that kind of leaves us with one last thing to chew on. Forget about math for a second. What's another one of those big ideas? Something that seems super simple on the surface, but once you get it, it completely changes how you see the world. Just something to think about. Thanks for tuning in.